Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 17 of your electronics book. This chapter is dedicated to transducers, marine transducers. How important is the transducer in the performance of your boat? Yes, the transducer is a good electronic equipment. The transducer is part of the rest of the electronic equipment integrated into the NEMA backbone. Alright, the transducer in general terms is basically your eyes in the bottom of the boat. Other names for the transducer is the depth finder or the fish finder. Those are other commercial names for the transducer. Really the transducer is part of the fish finder. The transducer is part of the depth finder. Those are complete systems. We are going to check a simple definition about transducers. A transducer is a device that converts one type of energy into another one. In general terms, a transducer is an equipment that converts any type of energy in other type of energy. For example, the speaker is a transducer. The transducer converts sound waves into electrical pulses. The knock sensor in your engine convert the sound, the knock, the sound into electrical pulses. There are millions of examples of transducers. In your automatic transmission, the transmission of your car, the transmission in your boat, you have a couple of transducers. There are millions of transducers that you use every day. The majority of the sensors are transducers because convert one type of energy into other one. Transducer. The conversion of the type of energy into other one can be from electrical, electromechanical, electromagnetic, photovoltaic, any other type of energy into other type of energy. The transducer may be categorized by the application, sensors or actuators or combination, both of them. Yeah, we study and we are going to study in the next books a lot of sensors, especially in the classes of diesel and gasoline. We are going to study a lot of sensors located on the harness of the engines. You remember when we designed the harness of the engine, the last episode of the chapter 14 in the electrical book, we connect a lot of sensors in the harness. Okay, a microphone is a transducer that converts acoustic energy into electrical pulses. This is other example. Example of transducer are load cells, force sensors, torque sensors, knock sensors, millions of applications for transducers. The microphone. A microphone converts sound wave into electrical current. The sound wave variations are first converted back and forth by means of a diaphragm. The diaphragm is a flexible membrane and deflect a potentiometer on the resistor, and according with the position of the potentiometer in the resistor, the output voltage is more or less. It's too simple. This movement then produces variations in an electrical current. Speakers are the final component of the audio chain. They are the interface between electrical signals and sound. The speakers are the first step or the last portion of the chain to convert electrical signals into sound. The term transducer is commonly used in two ways. The sensor used to detect a parameter in one form and report the parameter in another form, usually electrical or digital signal. And the audio loudspeaker, which convert electrical voltage variation representing music or speech to mechanical vibration. This is the typical example of those transducers. Marine transducers. Okay, the energy converted into the sensor is displayed in a graphical display such as the fish finder or the multifunction display. In the display you have the different variation in intensity, in amplitude, in order to check the shape of the bottom, the ground. This is one of the functions in the deep finder, and in the fish finder is working by the Doppler effect. The transducer is the sonar wave emitting portion of the fish finder. Yeah, the transducer is part of the fish finder. All right, marine transducers. We are going to study basically two types of marine transducers, depending of the type of hull and depending of the propulsion of the boat. Basically, if the boat is with inside engines, inboard engines, or outboard engines, they cannot withstand serious mechanical shock and should be cleaned every time the vessel is moved out in order to do the service for replacement of sinks and reparation of a propulsion system. Each time that you put the boat out of the water, the transducer should be cleaned properly with isopropylic alcohol, not with acetone. Alright, the transducers are divided in two types of transducers. Transom mount, like this, is mounted on the transom of the boat, or Thru-Hull, like this, is inserted in a Thru-Hull and the cable is connected with the computer. This is a Thru-Hull, the deck is located here, and this is a Thru-Hull. This is the sensor located behind of this crystal. This crystal is very important. This is the crystal that should be cleaned properly with alcohol and should be protected with a tape when you put the boat out of the water in order to tame the bottom of the boat again. Alright, the transom mounts are attached to the back of the hull, exactly like this picture. In this picture, this is the transom of the boat, and this is the transducer. It's a mount transducer. It's very common. It's very common in trailer boats. It's very common in outboard trailer boats. Be careful with this. The transom mount transducer will not work on a vessel with inboard engines. This type of transducer never works in boats with inboard engines. This is only for outboard engines. I am going to explain right now why. Because the excessive healing. Transom mounts are not recommended for sailboats. In sailboats, they are recommended Thru-Hull transducers. It is very important to locate the transducer in an area which is relatively free of turbulent water. What do you think? Suppose that this is the propeller. The propeller is located here in the middle. What do you think? Where should be located this transom transducer? In this position, this is the propeller, or here. And this is an outboard boat with only one propeller. Remember, if you have an outboard with only one engine, the rotation of the propeller is clockwise. The rotation of the propeller is clockwise. Okay, where should be located the motor mount? Here or here? Here or here? And why? Let me explain. Suppose that you have this situation. You have this situation. You have the outboard here. And this is the propeller. Alright, and this is the boat. Where should be located the transducer? Where is a good place to install the transducer? Here? Or here? This or this? Yes, the transducer is properly located here. Why? Because if I have one boat like this with a center outboard, the rotation of the propeller normally is clockwise in this direction. In other words, the water passes like this. What happens if I install the transducer in the other one? The water enter here and affect, because excessive turbulence, excessive amount of bubbles are located here and affect the response of the transducer. In this case, the water continue and the area in the bottom is clean and the response of the transducer is better. Yes, the answer is should be located here in the starboard side of the boat if you have a boat with only one engine. If you have a boat with double engines, with twin engines, the recommendation is basically the same. Install, if you have one engine here and the other engine here with the propeller here, the recommendation is install the transducer. This is the water line, install the transducer here. The transducer should be installed here. Never install the transducer in the middle and never install the transducer in the left side. The transducer should be installed here. This is the recommendation. Alright, we are going to return to this slide. Okay, keep up brackets. Move a transducer out of the way to prevent damage from floating debris when the boat is underway. A Transom Mount installation gives better performance than a Hull installation with speeds below 30 knots. The Transom Mount will not work in a vessel with inboard engines. That's an important recommendation. It is very important to locate the transducer in an area which is relatively free of turbulence. For that reason, this area is a good choice because the turbulence no affect the performance. Installation tips. The turbulent water is normally confined to areas immediately aft of ribs, strakes, or rows of rivets on the bottom of the boat, and in the immediate area of the propellers. For that reason, a good recommendations in order to install properly the transom transducer is this. If this is the propeller, if the propeller is located here, the recommendation is install the motor mount in an area separated minimum 40 centimeters from the external diameter of the propeller, 40 centimeters, and located in the starboard side. This is very, very, very important. This turbulent water is normally confined on areas immediately aft of ribs. On outboard or inboard outboard boats, the best recommendation is 40 centimeters to the side of the propeller. Okay, the distance between this point and this point should be 40 centimeters. 40 centimeters. This is the recommendation. in order to install properly those motor mounts. Alright, the transducer, other tips when you install the transducer. The transducer should be installed vertical. Doesn't matter if the shape of the hole is like this, never incline the transducer. Put the transducer vertical because the beam is perfect and the radius is more accurate. The transducer, when mounted, should be pointed straight down. The design of the transducer will accommodate a wide range of depth rises and remain ported straight down. This is very, very, very important. Other important recommendation is install the transducer with a continuous line from the bottom of the boat, exactly like this. This is a perfect example. This is the transom of the boat, and the middle of the transducer should be installed aligned with the transom of the boat. This is a good installation. This is a good installation. Look, this is the bottom of the boat, this is the bottom of the hull, and the middle of the transducer is located in the line of the bottom of the hull. This is a perfect installation, and of course completely vertical, no incline. First, adjust the pivot angle of the transducer body so its length is parallel with the length of the hull. Then pivot the transducer down so rear is about a 1/4 inch lower than the bottom. This distance in between this and the bottom of the boat should be a 1/4 inch. 1/4 inch. That's a good recommendation. Is a little lower. The middle of the transducer located a 1/4 inch below the hull of the boat. 1/4 inch. All right, that's an excellent recommendation. The most common procedure in order to pass the cables, in order to route the cables, the recommendation is pass the cables once again separated away from electromagnetic interference, away from the block of the engines, away from generators, from any equipment that produce electromagnetic interference. Pass that cable. This is a good installation. You make a hole on the transom, of course, over the water line, over the water line. I recommend, if it's possible, 2 feet minimum over the water line, or higher if it's possible. You make a hole and you pass inside of the boat. This is inside of the boat, and right now inside of the boat this is outside, and you enter inside of the boat, and inside of the boat you pass the cable separated from AC cables, from antenna cable, for grounding cables. The most common procedure, route the cable through the transom into the boat. Route the cable as far as practical from VHF radio or tachometer cables in order to reduce the possibility of electromagnetic interference. This is a very, very important recommendation. Thru-Hull transducer. Those are Thru-Hull transducers, the most common transducer for inboard boats, for boats with inboard engines, or this one. This is the example that we have here on our board. This is a transducer, good transducer. Both of them are excellent, and right now I am going to explain how to install those transducers. Okay, once again, all the transducers, they have the sensor. This is the sensor. This is the sender, and the sender finishes into the computer, and the computer is connected with the main screen. In the board we have the sensor, the sender, the computer, and the main screen. Those are the components of any type of transducer. Doesn't matter if the transducer is a transom or if the transducer is a Thru-Hull transducer. Thru-Hull transducers will work with any type of engine. This type of transducers, the Thru-Hull, work with both type of boats, inboard or outboard. This one, Transom transducers, work exclusive for outboard engines. Alright, this one, the Thru-Hull, work with inboards, with outboards, or with a steam drive inboard, outboards. And these transducers are right for power and sailboats. In other words, this type of transducer, Thru-Hull transducer, is the aspirin of the transducer. You can install this type of transducers in any type of boat. The most important when you install this type of transducer is the angle of the hull. The angle of the hull, like the picture that you have right now. That angle is critical because according with the angle, you select the transducer. You have the angle recommended here and you select the transducer because this transducer will be located like this or like this. Depending on the angle of the boat, these transducers work better if you select appropriately the angle of the construction. Right now we are going to talk about that. Alright, and also depend on the type of hull in terms of material. If the hull is in aluminum, if the hull is in fiberglass, and if the hull is in wood. Alright, if the hull is in aluminum, you need to be careful. You need to be careful if you have Thru-Hull transducer like this. This is a bronze alloy, copper. This transducer is good for an aluminum hull? No, aluminum and copper are the enemies in marine installations, in marine environments. You remember? Because the more noble metal attack the less noble metal, and the less noble metal at the end of the day will be corroded. What metal is more noble? Is copper. Copper attack the aluminum and the aluminum will be corroded. Alright? Be careful with that. For that reason, depending on the type of hull, we are going to install different type of transducers. The material of the body of the transducers are basically bronze, naval bronze, or stainless steel, like the transducer that you have on the screen right now, or reinforced plastic material, like the transducer that you have on the screen right now. Those are the most common materials. It's bronze, stainless steel, or reinforced plastic. Okay, we are going to check. If I have a boat with my hull in fiberglass, what type of material will be good for the body of the transducers? Bronze, naval bronze, or stainless steels, series 300, or plastic, reinforced material. Alright, for fiberglass will be good, both of them, stainless steel series 300, or naval bronze series 5000. Bronze or stainless steel will be excellent to work with fiberglass. What about reinforced plastic material? Yes, could be. For fresh water, could be excellent, good solution. If the boat is fiberglass, for fresh water, plastic material will be nice. Alright, what about if the hull of my boat is in aluminum? If the hull of my boat is in aluminum, the recommendation is use stainless steel series 300 for the body of the transducer, or reinforced plastic material. Yeah, if the hull is in aluminum. What about if the hull of my boat is in wood? For wood boats, the recommendation is use stainless steel Thru-Hull series 300, 306, 304, or 316 are excellent if the boat is in wood. Never use reinforced plastic Thru-Hulls in wood, because those plastic materials will be cracked depending of the deformation of the wood. Okay, I am going to install a transducer, Thru-Hull transducer in a boat, and I want to determine where should be located the transducer inside of the boat. What is the recommendation? What is the first step? The first step is select internally in the boat the best place where you think that should be located the transducer. The location of that area depends on what? Depends basically of the moisture, the humidity, and depend of the electromagnetic interference. For that reason, a good area to install a transducer, Thru-Hull transducer, is in the cabin, not in the engine room, because in the engine room you have excessive electromagnetic interference. In the cabin, in an area separated from generators or water makers, and in an area close to the keel of the boat, to the center of the boat, and in a dry area, no wet area. This is very, very important. All right, and with the minimum electromagnetic interference as possible. How can I check if my area is affected for electromagnetic interference? What is the tool recommended? Yes, the gauge meter that you have right now on the screen. This is a good tool in order to identify if that area is free of electromagnetic interference. All right, suppose that I have the decision in that area. I am going to install my transducer. I am going to make a hole over there. Before you make a hole, what is the first step? Try to verify inside of the boat and outside of the boat if this is a good place to make a hole. I recommend, if you have an old speaker, like the speaker that you have on the screen, and you have a piece of iron, a piece of steel, okay, locate inside of the boat the speaker in the area where you want to install the transducer, and goes outside of the boat and verify where the magnet is, where the piece of iron is attracted for the magnet. Oh yeah, in that place. Let the piece of iron attach to the button and verify if that point, that exactly location is good for the Thru-Hull. How you know if it's good? You remember in introduction? Yes, it is separated from the turbulence of produced for the propeller. Okay, it is separated from the turbulence produced for bow thrusters. It is not close to any other Thru-Hull, suction Thru-Hull for generators or engines. All right, those are important factors in order to determine if this point is good in order to install a new Thru-Hull. I recommend, if you are in a marina, ask to other contractors of other companies according with the location of that Thru-Hull. Say to them, hey my friend, I need an opinion. I am going to make a hole over there to install a transducer. What do you think? Probably with other opinion you can take a better decision. And finally, before you make a hole over there, call the captain, call the owner of the boat, make a video and send to them where you want to install the transducer and what is the opinion of them. This is very important. Probably they don't accept that location because they have in mind other project and they need that area for other purpose. All right? Before you make a hole, be 100% sure that this is the perfect location for the Thru-Hull. Ask to the captain, ask to the owner, and take in consideration other opinions from other contractors. Very, very important. All right, right now you are 100% sure that this is the proper location for the Thru-Hull. This is the moment you can start in order to make the hole. What is the first step? make a pilot drill from the inside of the boat to outside, like the pictures. Make a pilot drill and once again check outside of the boat if this is a good place. Alright? And right now, mark outside of the boat with blue tape the area where you want to make the hole. And now, with a caliper, check the diameter of the Thru-Hull, and with this diameter, select the appropriated saw hole. Select the appropriated saw hole in order to do the hole on the structure of the boat. And right now, prepare your drill with the hole saw. Select the hole saw appropriated according with the diameter of the body. The selection of the hole saw is very, very important. You need check if you have exactly the hole saw according with this diameter, because if you have a hole saw bigger than this, probably you have too much play and you have the possibility of leaks. Or if you have a hole saw a little smaller, that's a big problem, because when you do the hole, after that increase the diameter 1 millimeter or 2 millimeters is too difficult, and probably you have leaks in the future. You need to select exactly the hole saw appropriated for the body of your transducer. If you don't have the hole saw appropriated, I recommend that try to buy other set of hole saws, other brand, other manufacturer, because each manufacturer have different options in diameter, external and internal diameter. Be careful in the selection of the hole saw. And if you are not 100% sure about the selection of the hole saw, ask to other technicians with more experience about that hole saw. Believe me, this is a critical decision. You need make the hole exactly for the diameter of the Thru-Hull, the diameter of the transducer. If you have too much play, you have possibilities of leaks. If the hole is too small, after that, increase the diameter is difficult. And now we are going to start from outside. We are going to start to do the hole. And we are going to do the hole moving the drill, like the video that you have on the screen right now. And we are going to start to do the hole moving the drill slowly in circular paths until we pass the first layer of fiberglass. Immediately you pass the first layer of fiberglass, like the picture, we are going to remove with a flat screwdriver that circle. And after that we are going to penetrate the foam. And after that we are going to continue from inside of the boat in order to remove the second layer of fiberglass from inside. Exactly like the video that you have on the screen right now. This is the procedure step by step. Now, with the hole, we are going to cover inside of the hole with resin. Resin, the same resin that you use to do the fiberglass or the carbon fiber. We are going to cover that area with resin. And we are going to let 12 hours until the resin is completely dry. Now the hole is ready, and we are going to insert the transducer into the fiberglass. The first step is introduce from outside to inside the cable, the sender. One person introduce the cable from outside, and other person inside of the boat receive the cable and pass the cable through the hole. And right now the transducer, the body of the transducer, enter into the hole, and the other person inside pass the nut through the cable and bolted the nut on the transducer until the nut touches the fiberglass. Before the nut touches the fiberglass, it's good idea apply 5200 around the body, used in the bottom. Some manufacturers, they have a gasket, a foam gasket in the bottom in between the hole and the nut, in order to avoid apply 5200. However, I recommend apply a little amount of 5200 on that area in order to avoid future leaks. Right? Right now, with the properly pipe wrench or channel, you can tie the nut slowly. The other person outside attach the sensor in order to avoid that the transducer be moving, and the technician inside tie the knot, not too much, until the sensor is properly torqued. The next step is, with the rack impregnated with a mineral spirit or alcohol, isopropylic alcohol, clean the excess of 5200 in both sides, externally and internally. Clean the excess of 5200. And right now, with the sender, with the cable, the next step is connect the cable into the input of the computer. The computer have 3 terminals. One terminal to connect the sensor, other terminal to connect the power, and other terminal is free in order to connect the computer directly into the backbone. If you prefer, connect the computer directly into the backbone, or if you wanted to connect the computer into the main screen. That's your decision. And other port, the last one, is used to connect the computer, the laptop, in order to do troubleshoot during the installation, or troubleshoot in the future if the fish finder or the transducer is working erratically. This is the procedure. And finally, the computer is connected with the main screen or with the backbone. This is the procedure, the simple procedure to connect the transducer. And doesn't matter if the transducer is a Thru-Hull transducer or a Transom Mount transducer. The transducer should be clean. The crystal of the transducer should be clean, and the cable should be routed, appropriated, away from VHF cables, AC cables, lighting cables, and any other equipment that produce excessive electromagnetic interference. Okay, I hope you enjoyed this video. I hope that you visit my webpage, mrlopezclases.com, my YouTube channel. I want that you subscribe in the YouTube channel. Thank you.